All right, so in this video we're going to be talking about cardboard as an engineering material and understanding its properties and its limitations and how to build considering those, what we can say as constraints. So if you look at cardboard here, you can see that it is composed of basically paper, and if I hold the camera, if I hold it just right, you can see that you can actually see through the cardboard. It's mostly air, and that's one of the really important properties of cardboard, is it makes it pretty strong for its weight. So it's basically sandwiched paper. So you've got, let me jump over here to this this picture here. So you can see there, you've got basically one layer of paper and then separated by another layer of paper. In this case, it's double thickness. And then you've got this corrugated piece of paper that runs to connect the top and the bottom layer, and it's glued together. And if I jump back over here to this camera, you can see I've actually peeled this piece apart, and you can see that it's that corrugated piece that's just got glue that had previously glued it down to this center, that middle layer of paper. And then there's a top layer that you can peel off as well. And then you've just got that slightly thicker piece of corrugated paper that runs in between and gives it so much of its strength. So basically, whenever you're thinking about engineering with cardboard, you need to think about the direction that corrugation runs and how you are going to use the piece of cardboard to carry load. So paper is not very strong with compression. So if I take this paper and I try to smush it together, it can't take very much force before it buckles. It would be like taking a piece of string. I can pull hard on the string, and the string's got a lot of strength if I pull on it, but if I push on that piece of string, it doesn't have much strength at all, and paper's the same way. So we need to think about that whenever we're thinking about how to load that paper. So here in this, this picture, you can see I have, if I were to put a weight right here in the center of the cardboard, and that's going to be pushing down right here, then that means that this is going to want to dip, right? And if it tries to dip, then that top layer is actually getting smushed together, and that's what these red arrows are right here. You can see that this top layer of paper is going to be in compression as this piece of cardboard tries to bend this way with a weight there in the middle. And that means that the bottom is in tension. Now, is this paper in tension going to do pretty well? Yeah, it will. Paper is going to do pretty well in tension, but it's not going to do very well in compression. So where's the weak point going to be? The weak point's going to be this spot right here. It's going to get pressed on this side, get pressed on this side. This is assuming that the load is actually located in the center. And then that piece of paper right there, where it's not supported here or here, that piece of paper right there in the middle is going to buckle in, and that's where the cardboard will bend. If we have a load coming up from the bottom, in this case, it just so happened that it hit a center part where it's supported. Again, this thing's going to want to bend this direction right here. And whenever it does, that top part's going to be in tension. So that paper up on this top layer is going to do pretty well because it's in tension, but this bottom level is in compression. It's supported right here in the middle, so it will probably either bend here, where it's unsupported and it's going to be in compression, or here. One of those two places will probably be where it creases and bends. So let's go ahead and, let me jump back over. Let's go ahead and look at what will happen if I try to bend this piece, for instance. So let me get this right up to the camera, and I'm going to apply a force right here by bending and putting pressure on my thumbs. And what's going to happen? It's just going to bend. Super easy. That was not much pressure at all. And let's see if we can see, where did it bend? Did it bend? It bent right in that crease, just like what I said. Two of those creases, it was where it was in compression that the bend happened. And that did not take much force at all. Now, the reason that it didn't take much force at all is because I oriented the cardboard this direction, and it's super easy for it to bend that way. But what if instead of cutting it with all of the holes being on the long side, I cut it with the holes being on the short side, so that those channels are running the whole length of the piece of cardboard? Well, now let's apply pressure. And I'm applying more pressure and more pressure and more pressure, and finally it will bend. But notice, is that a straight line? That's not anything like how this one failed. This one failed a very clear spot. This one had to crush lots of random places for it to be able to bend. And it was a lot stronger in this direction. So, if I know that I'm going to have, just like I did with my glue gun holder video, if you've seen that one, if I know that I'm going to have a long run that's going to hold some weight, I'm absolutely not going to build this way. I'm going to make sure that I cut with the long lines in the direction of the longest side, so that it will take the most force before it will bend. So whenever I did my shelf for my hot glue gun holder, I absolutely had the lines running this direction. But what happens if our shelf or our design needs to take load in multiple directions? How could we make a piece that's going to be strong? What if it's a square? What if it's a larger square? And we need to figure out a way so that it's strong this direction, but it's also strong this direction. What could we do? Well, we could take a piece of cardboard that is oriented this way and another piece let me cut this real quick. Oriented this direction. So we alternate. So this one's, the lines are running this direction. This one, the lines are running, those channels are running this direction. And we could take a glue stick or a hot glue gun, and we could laminate these pieces of cardboard together, so that now if we have load wanting to bend this way, this piece is the strong piece. And if we have a load wanting to bend it this way, then this piece is the strong piece. So we can laminate or combine cardboard so that it can overcome those stresses depending on how we're going to be using it. So you need to think about tension and compression. This is not just true with cardboard. This is true with metal, with wood, with any of the materials we're going to be using in this engineering course. But especially with cardboard, the way that it's designed, it's much stronger in one direction than it is in the other. You need to think about that with your designs and how you lay out your designs, so that whenever you cut them out, you'll have the most strength for what you're trying to prototype or build. Hopefully that's helpful.